Welcome to LMP Simulator. Today we are going to discuss about electrical fundamentals, some of the basics that we want to learn before trying to enter into the electrical sector. So what are the most important fundamental things that we are going to discuss today? So first and the foremost thing is that in the electrical fundamentals, three people plays a very important role. One is the resistance, and the second one will be the voltage, and the third one will be the current. Okay, so this voltage and the current properties, okay, it changes based on the load, okay, based on the power that we are going to provide. Here, consider a situation, okay, we have a constant load. So what will happen during the constant load? So we already know it, okay, R is equal to V by I. R is here the resistance and V will be the voltage and I will be the current. It means that if the voltage increases, the current will also increases when there is a constant load condition. Okay. Consider a situation there is a constant power. Say for example, okay, even though if you are trying to step up a voltage of 10 volt, okay, 100 amps load, okay, current into 100 volt 10 amps, okay, so we already know it, P is equal to V into I. So here V is voltage 10, okay, 10 into 100, it will be 1000 watts. So 1000 watts is going to be your load. So what is happening here is that when we step up, what is happening? The voltage is stepping up, okay, and the current is getting reduced. See here what is happening. The 10 volt is converted into, when we step up, just an example I am telling, 10 volt is converted into 100 volt, and a 100 amps load current is getting converted into 10 amps. So that the power here is going to remain the same. Okay, only thing is that a change is happening in the voltage and in terms of current. So it means consider a situation if there is a constant power, okay, we have a formula P is equal to VI cos pi. Cos pi is refers to, pi here refers to the power factor. So it means even though if you are generating a power of 66 kilovolt, that is 7.5 kilo amps, okay, if you are trying to step down that current, that generated voltage to 220 kilovolt, okay, so it means here you are increasing the current. So here the current has been increased from 66 to 220. It means you are making some step up operation. Consider we have a 500 megawatt power station, but see the current has been reduced from 7.5 kiloamps to 2.2 kiloamps. So this is how some of the important conversion which is being happening in the step up process. Okay, and if you want to convert, okay, any sort of parameters, okay, whether it can be a AC power or a DC power, or it can be a real power, reactive power, we have some sort of conversions. If you want to convert, okay, the existing to the actual power, you can use S into 0.8, or else if you want to convert, okay, HP into to actual watt power, means you have to use this formula. Say for example, so 1 HP is equal to 746 watts. It means if you want to convert 1 HP value, okay, horsepower value in terms of power, normal power, it will be 746 watts. Okay, so consider you have a 2 HP, means you need to multiply. If you want to get the power value in terms of watts, you need to multiply this HP power, 2 HP power, it means 2 into 746. So this is going to be your value of watt. Okay, so this is how you need to make some sort of small conversions. Apart from it, there are so many electrical to mechanical conversions, mechanical to electrical conversion. For this, you can use this formula. If you want your HP mechanical value into the electrical power value, you need to use this formula. Or if you want to convert, okay, any sort of existing powers in terms of HP, you can use this formula. Or if you want any sort of mechanical conversions, if you want to convert any sort of electrical values into mechanical conversions, you can use these formulas. Okay. Next and foremost important thing which we often consider in terms of windings which is being present inside the motor or a transformer is that star delta connection. So this is going to play a very important role, because Consider this is the delta connection. As you can see here, it is in the shape of delta. Here, if we calculate the line voltage will be equal to the phase voltage. So consider this is the phase voltage. If you are measuring the line voltage, both are going to be the same. But when you measure, if you want to calculate the line current, you need this formula. It means it is line current will be √3 times of phase current. Means so line current will be lesser than this phase current. That is a calculation they are trying to put forth. And if you want to calculate the power, you can use this formula: 3 into V phase into I phase into cos pi. This is going to be your value for calculating the total power in the delta connection. Okay. We have so many electrical devices. We all know it. If you want to convert any sort of electrical power to a mechanical power, you need most important device named equipment named motor. So motor is going to convert your electrical energy into the mechanical energy, electrical power into the mechanical power. And next important device is going to be the generator. What generator is doing? So you are converting a mechanical energy, to the important role of this electrical equipment. Generator is that it converts the mechanical energy into the electrical. It means mechanical power is getting converted to electrical power. And what this transformer is doing? In transformer, simple, for the stability purpose, for the maintenance of power factors, and for the long time transmissions, with the help of transformer, we can either do step up or step down of electrical parameters, especially the voltage and the current. And here the power is going to be the same, because we are providing the electrical power only as an input, and also we are taking the electrical power only as an output. The power is not going to be changed. So here only the conversion or step up or step down is happening only in terms of voltage and the current. Next, there are three different kinds of power. We all know is real power, reactive power. Like that, we have so many parameters. If you want to calculate it, use these formulas to calculate the real and reactive powers which are being available in the electrical fundamentals. And most importantly, we have two different categories mostly. Apart from there are so many categories, but still we have two different categories. One is British standards, the other one will be the American standards. So according to the British standards, the frequency range will be 50 Hz. In India, we are following the 50 Hz range. If you are in America, then you might be following 60 Hz frequency range. And if you are going for a voltage, normally if it's a single phase, we used to go with the 220 volt, and if it's a American standard, it will be 110 volt. And if you are going for a line voltage, in case of star connection or delta connection, it is going to be 380 volt, and if you are going for American standard, it will be 220 volt. So, and most important thing is that if you are trying to pass a current through a wire, so current is directly proportional to the cross-section area of the wire. Cross-section area of the wire. It means smaller the cross-section area, it will try to use all the conductors to pass the current through it. If you are trying to utilize the cable with a larger cross-section area, current always try to use the least resistance part. It means the conducting process and the resistance will be more, and there will be some sort of lossages. So better, based on the requirement, based on the current, choose your conductors. Try to have a conductors with a small cross-section area. And the next most important thing is that when you are getting into industry, when you are getting into your power plants, or when you are trying to sort out the load, if you want to do any sort of load calculation, if you want to know what is the power source which I need to provide, what is the current source which I need to provide, what is the voltage source which I need to provide, how much load it is going to consume, what will be its efficiency. If you want to know all these details in case of motors, you can see all these details in the nameplate which is being provided in the motor. So in the nameplate, they will clearly provide what is its frequency, what is its mechanical power, how much HP is going to be, and what is its line voltage, and what is the line current, and what is the efficiency. All these details you can see it. So we all know it. Efficiency is equal to P output divided by P input, which is the P mechanical is going to be your output and P electrical is going to be your input. So it means P in is equal to 150 divided by 0.943. It means if you are providing 150, if you are providing, consider your efficiency is 0.943%. How much electrical input you have to provide? It means 159.5 HP power you need to provide in order to get an output of 150 HP. It means, and also most importantly, its efficiency will be 0.943%. Okay. Same way, the rated value plays a very important role. Based on the rated value or the nominal value of a power, voltage, and the current, okay, of that particular device, we can give the optimal performance. Okay, if we try to operate the devices, okay, electrical equipment, example is motors in its rated value. So as you can see here, they also provide the tolerance ranges also. Tolerance range can be 10% in case of voltage, plus or minus 5% in case of frequency, and same 10% plus or minus in case of current, and the speed also varies plus or minus 20% when considered to rated slip RPM. Okay, efficiency range will vary minimum 20%. Okay, and what are the different sort of voltage ranges? So as you can see here one of the voltage range is missing, that is nothing but the extra low voltage. So if you are going for extra low voltage value, whatever the voltage which is less than the 110 volt, it can be either 24 volt or 12 volt, all these categories, 5 volt, all these categories will come under the extra low voltage category. So in the low voltage category, it will be in the range of 110 volt to 220 volt or up to 380 volt. If you are going for a medium voltage range, it can be from 11 kilovolt to 66 kilovolt. Okay, in case of either this 2.2 kilovolt, 3.3 kilovolt, 6.6 kilovolt, 22, 33 kilovolt, all these things will come under the medium voltage category. The example is you can use the locos, which is being that is loco trains, which is being operated in the railway station. So all these standard railways, Indian railways, will be using this medium voltage range. Okay, and most importantly, during the power generation and all, we might be using this ultra high voltage range. It will be from 750 kilovolt to 1000 kilovolt or 1200 kilovolt. Extra high voltage will be in the range of 500 kilovolt to 750 kilovolt. Okay, high voltage will be in the range of 66 to 500 kilovolt range. Okay, so what this power factor is going to play a very important role. Means power factor here refers to, now we all know it, is a power factor value will be either unity or maximum 0.9%. So it should not, we need to try to achieve the unity power factor. Okay, for that purpose we need the important help of this transformers. We all know it, even though we are stepping up the power which is being generated in the power station. Okay, why don't, instead of sending it directly to the load which is being present at the consumer side or the customer side, what we are doing, we are trying to step up this voltage which is being generated in the 500 megawatt power plant, and with the help of a step up transformer we are trying to step it up. Okay, and we are trying to transmit it through the transmission lines. Okay, example, as you can see, you can tangent go. Okay, tangent go is Tamil Nadu Generation and Distribution Corporation, tangent go. So here what they are doing with the help of transformer, they are stepping up the electrical energy power voltage which is being generated at the power plant. Okay, and they are trying to send them through the transmission lines, and when it is trying to reach the consumer or the customer where the voltage recommended is only 2 kilowatt, with the help of the step down transformer we are reducing that voltage and we are replacing our power. Okay, so why first and foremost thing is that why this power factor is very much important. As you can see here, if 100 watts fan, okay, if it is power factor is 0.8, okay, as you can see here, the real power and the reactive powers, okay, all these considerations will be little more, but still if in case of efficiency wise it is very less. But when your power factor is 0.9, okay, it is also the same 100 watts panel, 100 watts fan means here the efficiency is good, performance is going to be the good. Okay, so if you want to calculate the power factor, you can use these formulas. So, and most important thing is that we need to know the power system process. So here generator is doing the generation process, and next thing is that whatever being generated, the voltage which is being generated in the generation station, okay, we are not transmitting it directly into transmission lines. We are stepping up those voltage which is being created with the help of a step-up transformer, and we are transmitting them with the transmission line. Transmission line ranges can be 500 kilovolt, 345, 220, 180 kilovolt, or something like this. So many things are going to be there. So this is going to be the transmission customers who is going to use 180 kilovolt or 230 kilovolt. Okay, and then when it comes to the sub-transmission line or primary customers or secondary customers, especially who is going to use these different loads at different ranges, what we are going to do after the passing through the transmission line with the help of the substations, what we are going to do, we are stepping down the voltage which is being transmitted. Okay, so that what we are going to do, we have three different customers. So the sub transmission customers who is going to use 26 kilovolt and 16 kilovolt. So from the step down, we will be providing the conserved required voltage to them. And if you are going for the primary customers, same 13 kilovolt or 4 kilovolt we used to provide to the industries. And our normal customer ourselves, we will be using either 230 volt or 240 volt. Okay. Next, the main parameters of electrical system is going to be the power, and its unit is going to be in watts. So if you want to calculate the power, P is equal to VI cos pi. So the pi value is going to be your power factor. Okay, V is the voltage and I is going to be your current. Okay, so if you want to calculate the rated value or the nominal value, you can see the nameplate details of the motor. This is the nameplate. When we expand and view it, you can see the frequency range, you can see the mechanical HP power, you can see the voltage, line voltage, you can see the line current, and most importantly you can see the efficiency ranges also. Okay, so how can we relate the DC power and AC power? How to calculate what are the different formulas? If you want to calculate the DC power, it's very easy. P is equal to VI. That's it. If you're going for a single phase, it will be PI cos pi. If you're going for a three phase, it will be 3 into VI cos pi. Okay. So now consider the power system process fundamentals. Okay. Here, most importantly, if you're going to utilize on the distribution side, okay, consider you had created a ring main unit. You have three different stations. Okay. Three different generation stations. Okay, here the most important thing, if you want to connect them in a single bus bar, okay, which has an infinite bus bar, ring main unit, you need to have a same voltage, same frequency, and same phase shift. All these three things should be same. Means voltage and frequency should be the same in all the three generation stations. Consider on the distribution side you have a load. Okay, so this is the scenario we are going to make. Here on the load side we are going to make some changes. Based on that, we are going to calculate how it is affecting the frequency. Okay, how it is affecting the power, how it is affecting the voltage, how it is going to affect the current. All these things we are going to see. Consider if you are doing a speed control. Okay, you have a load shedding happen. Okay, and if you want to run them, okay, consider a load shedding has been happened. Okay, if you want to run them with the existing three generating stations, the loads, it means consider normally to run these two loads we need 4 generators. Consider a load shedding has been happened, one station is not at all generating any sort of power. Now it is your duty to run the entire load with the available 3 substations. So it means here the overloading is going to happen. So what is happening here? The load is increasing. As the load increases, current also increases. When the current increases, torque increases. Okay, but when the torque and the angular speed is inversely proportional. As the torque increases, the angular speed will also reduce. When the angular frequency is going to reduce, angular speed is getting reduced. It is directly proportional to the frequency. It means W is equal to 120 F per P. It means the frequency is getting reduced. So when you are going for speed control process, when overloading happens, so this is how changes which will happen in the frequency. So it means the frequency drop will be happening when we are doing the overloading. Okay. In the same way, okay, consider the situation. Okay, here also the overloading is happening. Already, we know it. One substation is not working, not active that much. Okay, we are running it with the available 3 stations. But normally only 2 loads we used to run. But here we had increased the load. So since we are increasing the load, what is happening? When the load increases, current increases. When the current increases, torque increases. When the torque increases, what is happening? The angular value is getting reduced. The angular torque value is getting reduced. What is happening? The frequency is also getting reduced. Means we have a frequency deficiency, which is happening here. consider a situation. Now what is happening? We have removed the existing two loads which was being connected in the distribution line. Now we have three substations. Okay. Here what is happening? We have excessive power. Means we have very less load. So when the load reduces, current also reduces. When the current reduces, torque also reduces. When the torque reduces, angular value will increase. When the angular will increase, the frequency ranges will be very high. Okay. So in order to do the speed control, it means the frequency control, we are using this formula concept. We have so many parameters. It is from the turbine, okay, steam valve. We are making it high pressure, and we are trying to run the turbine. When it crosses through the turbine, the high pressure is getting reduced to low pressure. Then with the help of the exciters, okay, what is happening? We are trying to generate the voltage, and in order to regulate the voltage, we are using the voltage regulators, and it is connected with the network and the infinite bus bar. So this is how basically the things are happening in order to control the exciter speed, okay, and also steam valve opening and closing. We are using the controllers and the servo motors and hydraulic plates. Okay, so this is the star connection. So in the previous slides we have gone through the delta connections. Here star connection. If you are going for a star connection, the line voltage is √3 times of the phase voltage. The line current and the phase current is going to be the same. So as you can see here in the delta, the voltages are same, but the current is getting different. But in case of star connection, what is happening? Voltage is √3 times of line voltage is √3 times of phase voltage, whereas the line current and phase current are going to be same. Okay. If you want to calculate the total current in the star connection, you can use this formula: V into V phase into I phase into cos pi. Okay. So how can we identify, okay, the windings, okay, which is being present inside a three-phase induction motor, okay, three-phase or asynchronous motor is being in the star connection or delta connection. As you can see here, we have a symbol here. This is a delta to delta star connection. This is also a delta star connection. Okay. As you can see here, what is the rated voltage, how you need to make the connection terminals, how you can get your line outputs, where you have to connect your line and where you need to connect your load. All these provisions has been provided here. So by seeing, reading this enabling details properly, we can able to identify what is a connection, whether it is in the star connection or a delta connection or star delta connection or delta star connection. We can easily identify. As you can see here, this is a simple example of a delta star connection. This is a transformer. When you look into the catalog, you have a clarity that how the coil windings has been present here. This is an example of a transformer of a delta star connection. Okay. So as we told earlier, okay, in the exciter and the voltage regulator and the field winding side, okay, the most important things are happening here. Power is getting produced, okay, voltages we are having a frequency, and most importantly, mechanical power is getting converted to the electrical power. Okay, this is how the steam generated full system is going to be. As you can see here, when the steam is coming from the boiler, with the help of a steam valve, we are trying to control the flow of steam. Okay, we are trying to make it a high pressure. Because of the high pressure, that we are trying to run the turbine. Okay, and when it crosses through the turbine, the pressure is getting reduced, and we are trying to reuse it for the high pressure side. And then with the help of the voltage regulator and the generators, we are trying to generate the power. And in order to make a monitor each and everything and the control of the entire generation, we are having a controller in the servo motor and hydraulic relays. And the most important thing when you are designing is that voltage, because voltage is directly proportional to the insulation. Okay, it means if you want to send high voltage, you need to have a proper windings, and also most importantly, insulation is very much important. Okay, for the protection purpose. So as we told earlier, the exciter, when the excitation reduces, the voltage is getting reduced. Okay, when the excitation increases, here the voltage control we are doing, the voltage generation will also increase. So the same fundamentals which we had already gone through it. So low voltage category will be 1 to 1 kilovolt, medium will be from 1 kilovolt to 66 kilovolt, high voltage ranges will be from 66 kilovolt to 500 kilovolt. If you are going for an extra high voltage, it will be from 500 kilovolt to 750 kilovolt, and ultra high voltage will be from 750 kilovolt to 1200 kilovolt. Okay, so this is how the power system process is going to happen. And most importantly, with the help of in the transmission line side, we have a tap changing transformers. By changing the different tappings of the windings, we can take the required output with the help of a tap changing transformer. Even with the help of a tap changing transformers also, we can control the speed. So the best example of this tap changer is that in the loco train loco engine. We have this tap changing transformer. Only with the help of this we are controlling the speed inside the loco train. Thank you so much. Please subscribe and press the bell icon. If you want to know more and learn more, okay, you can subscribe to our channel. Okay, we have provided our contact details also. Okay, if you have any sort of inquiries, you can WhatsApp us and you can mail us. And we, as a LNP Renewable System Integrator, we are providing PLC programming training for Siemens, Allenberg, Delta PLC. And if you want to work in GCC countries like Qatar, Oman, Saudi, and Dubai, especially in the building management system, building automation control system, you can contact us. We are providing training on it. Okay. Most importantly, to whom we are providing? We are providing training for the working professionals who are already in the electrical field, especially in the PLC programming field and the building automation field, and most importantly, building management system field. And people who are students who are from EEE department or electronic and instrumentation engineering department or ECE department, and most importantly instrumentation and control department, we are providing the training, especially in the PLC and most importantly in the automation sector. And you might have a agriculture farms. If you want to protect your crops from the wild animals intrusions, instead of going for normal fencing, you can use the solar fencing. We are providing them as a kit also. And most importantly, EV power is not available. If you want to establish light connections there with the help of the solar energy available, then we are providing, we can able to support you solar DC light system there. And most importantly, we as a LNP Renewable System Integrator, we are providing basic trainings in access control system, PAV system, fire alarm system, structured cable system, like so many things. So when you subscribe to our channel, when you get into your playlist, when you listen to our videos, so many things are available. We are providing our videos in 4 different languages: English, Tamil, Malayalam, Hindi. Please make use of it. Thank you so much.